Well, welcome back to the Azure Podcast. This is episode number 481, being recorded on the 18th of December, 2023. Today, it's Cale and myself, and we're going to talk about the AKS Fleet Manager, which is a new service that the AKS team announced. And I think it's interesting for our enterprise customers that are using Kubernetes. So we thought we should dive into it before the year ends over here. And but before that, let's just get into some news. Cale, I believe you had an item to talk about.
Yeah, the one I want to talk about is, we've been talking a little bit about custom silicon. I think we talked about that as part of Ignite, some of the custom silicon that Microsoft's working on. But along with that, there's a GA announcement for if you're working on Azure Functions to support the Apple Silicon Macs. So these are basically the M processors from Apple. And basically what this allows you to do, this is a GA for Node.js, .NET, Python, PowerShell, and Java. So when you're writing your Azure Functions, the local dev environment, if you're using one of those new Macs, there is support for that now that's in GA. So should be great.
Awesome. I had a couple of updates, a few of them related to databases in Azure. The first of them is the MySQL database. So MySQL now has the option of using faster storage for the transaction logs. And what that means is that it's less overhead because transaction logs are very important for the database to make sure that all of the writes are being stored somewhere so they can be replicated out or used for recovery purposes if required. And that typically tends to be an overhead because it's done synchronously. And now you could do these transaction logs, a lot faster, and therefore the kind of throughput of the server will improve. So that's one update that's in public preview. The other one is for PostgreSQL, which is one of my favorite databases these days because a lot of my customers tend to use it. And so the flexible server SKU now has the disaster recovery features available. And the way they do that is, of course, you can deploy to multiple regions, but then you have something called the virtual endpoint. Right? So you're connecting it to not through individual servers, but to a virtual endpoint, and then you kind of just have to change through a command. You can say, okay, this is my primary, that's my backup, or vice versa, and then the applications just continue working like as if nothing happened. So that's a new feature in PostgreSQL, also in public preview. And finally, Oracle and Microsoft have announced a nice partnership where the Oracle infrastructure is actually hosted inside. So the Oracle data center is hosted inside of a Microsoft Azure data center. And so you have all of that support from Oracle in terms of how they would deploy an Oracle database, but it's completely inside of the Microsoft Azure, so you can access it from Azure as well. So that's also generally available now. So certainly look forward to that if you're using Oracle. I think that's it, right? Anything else you want to talk about, Kel?
No, I think that's it. We can get into Fleet Manager.
All right, let's talk about that. Cool. Yeah, so this was an interesting one. I think we've had a number of discussions about AKS in general, right, over the years on this podcast, and it's pretty clear that Kubernetes and AKS have become very popular. Our customers are using it more and more just because of the advantages of kind of consolidating all their application deployments and development under that one umbrella. But just as the number of AKS clusters or Kubernetes clusters is increasing for the customer, the headache to manage them is also increasing, right? And so so there are a number of solutions that have come into play to help manage the sprawl of Kubernetes clusters. And the AKS Fleet Manager is one feature that Azure has introduced to help with that kind of sprawl. Now, one of the things when you think about why Fleet Manager is kind of required, because an AKS cluster, as you know, can scale up, right? You can add number of nodes, and in some cases you can go to hundreds of nodes, right? You're just limited by the number of IP addresses that you can allocate to that cluster. You could say, okay, I can have a really large cluster, and so what's there to manage, right? I'm only managing one cluster. But most customers, don't use AKS in that large scale manner. They'll typically have, regional deployments of AKS. So obviously in different regions for load balancing and also for regional availability as well as for lower latency to specific regions, right? If you want to serve customers in that region, so that's another reason why you would kind of spread those clusters out. You also want to have maybe a dev, QA, and prod cluster, right? You know how people like to kind of segregate that out. And finally, there are some workloads that are just too sensitive to be shared with others, right? You want your own cluster; it's completely isolated, and you don't want anybody else on it. So there's all these reasons why you have like hundreds, if not thousands, of clusters, right? That are kind of lying all over the place. So that's kind of one of the reasons why things like Fleet Manager and other tools for managing number of AKS clusters or Kubernetes clusters has come about.
Yeah, one of the things I was going to say, Sujit, is like customers I've spoken to and some partners, they were interested, and I wonder if this solves the problem of saying, hey, I have inside AKS cluster, basically we have some node pools that are servicing some different services that are being exposed there. But then they have like a single load balancer. And it seems like there's some like ways to do like annotations and things like that to kind of influence how AKS provisions some load balancers. But at the end of the day, some of these partners ended up spinning up multiple clusters because they wanted these dedicated endpoints for each one of those kind of things, and then they had something sitting on top of that. But then, as they came back, they said, the pain there now is going to be like, I got all these clusters I have to maintain out here. How do I do it? So I think this seems like a perfect fit for that type of scenario.
Yeah, yeah, and some of the when you talk about management problems, right? They fall into two categories, generally, maybe three, but let's start with the first two, which is uh, just keeping the infrastructure up to date, right? I think from compliance and security perspective, you want to make sure that you're on the correct version of Kubernetes, right? Because Kubernetes, as you know, is something that keeps getting worked on, and there's new versions coming out. You either have security patches in those new versions, or you just want to take advantage of new features, new custom resources, etc., that are coming out. So that's kind of one problem where we keeping the Kubernetes version up to date. And then the other problem, which most specific to AKS, is the version of the node image, right? So when you boot up a node, it uses a specific disk image, and you want to make sure that that disk image is the latest that's available, right? Has all the security fixes, et cetera, to support that Kubernetes cluster. So that's one kind of problem is, how do you make sure that all your clusters in your environment are at the correct Kubernetes level and at the correct node image level, right? Which your security and compliance folks have signed off on. So that's kind of one of the main reasons why that management becomes a challenge, because you have this sprawl otherwise, and you're worried that you're going to be susceptible to some sort of an attack. The problem that they have is just the number of applications that are deployed on your Kubernetes clusters now, right? Again, managing that across at scale is becoming difficult. So if you do have multiple clusters, let's say you have multiple dev clusters, QA clusters, production clusters, whatever, and you want to make sure that there are some things that should be there across all of them. Maybe they should all have let's say a specific daemon set, which does some sort of logging or monitoring in your system, or they all should have some workload, some application, some service. How do you do that? How do you make sure that all of them have it, right? So that's the other problem, is that you want to make sure that there's consistency across all of the clusters from an application and workload perspective. So those are the two primary reasons, but the third one, like you mentioned earlier, Cale, is then how do you load balance across some of these clusters? If these clusters are going to share the same application, and you want to make sure that they load balance across clusters, you need a solution for that too. So these are the three problems that the fleet manager is trying to solve. Okay, that's kind of where it all starts in terms of the problem space.
Oh, on the update piece, if you could drill into that for a second, like one detail question I had there was around It's great to say we have a single pane of glass to manage all these AKS clusters and make sure those, the node images and the Kubernetes version are up to date and these kind of things. But a lot of times we want to do like kind of blue-green testing, or we don't want to like just immediately upgrade everything, right? We would say, hey, let's do dev first, make sure everything's cool, and then we'll go up through those. So I assume, is that true that like Fleet Manager allows you to kind of manage that? It's not just like turn on auto updates. It's more like, no, I actually have controls here about like controlling what's there, but it's actually showing me like what's going on.
Absolutely, yeah. And so that's a good point. So this is the resource propagation feature that you're talking about, right? Where you want to make sure your application that are deployed to specific clusters, right? Now, like you said, your fleet, right, could contain thousands of clusters, let's say, right? It doesn't mean that the same app, all of them are going to get the same application, right? You want to segment them. And that's a good point, good call out. So when you create these resources, they're called cluster resource placement resources. That's what they call them, right? So when you create a cluster resource placement, you first tell it, okay, I want this namespace to be rolled out, right? And then the second part you have to tell it is, what is the policy to roll it out? Who gets it, right? And here you can provide different things. You could say, I want to use label selectors, for example. When you roll out AKS clusters, you provide labels. Maybe there's a label called tier is equal to production, or application is equal to blah, or whatever it may be the case, right? So you can mix and match those labels to create these groups of deployments. So you can say this resource group gets deployed to all of the production clusters, right? Or that resource group goes out to the dev clusters, and so on and so forth. So there's ways that you can target different groups of clusters, and you can create those groupings. And what the resource propagation feature does, it has the scheduler, which is part of it, which will kind of come in and in a batch mechanism, it will try to update all of the various clusters without impacting them, with minimizing the kind of workload impact that may have. So the application can still keep running, but then slowly over time, these clusters will be updated to the next version, if that's the case.
Yeah, along
And
with that, you mentioned. Oh, sorry. Go ahead. Go ahead, Sudhir.
No, I was going to say it's not just applications. So I said application, but applications include things like, all sorts of Kubernetes resources, right? They could be services, secrets, whatever, anything else. Anything that's in a specific namespace in their Kubernetes cluster can be pushed out.
Yeah, maybe you could talk a little bit more about the. You kind of mentioned there's a relationship between like Fleet Manager and these AKS clusters. I guess the question I have is like, what is that? Do these AKS clusters even know they're being managed, or are they just receiving commands just like if they were a Kubernetes cluster and you were sending commands to them? Is there something, an agent, or is there something that happens over there?
That's a really good question. So when you obviously everyone's already got like all these Kubernetes clusters already there, right? So you're starting off from a place where you have these many Kubernetes clusters. Now, when you create a fleet manager resource in Azure, right, there's two ways to create it. If all you're interested in is the update orchestration, in other words, keeping the Kubernetes version and the node pool image up to date, so that's called the update orchestration. If all you're interested in that, then you just create an AKS Fleet Manager resource in Azure. You don't need anything else other than that resource in Azure. And then you can, once you have that, you can define groups of clusters. You could do like a set of dev clusters first, update the node pool versions there, make sure they work correctly, then do the QA production, whatever. So that's just update. That's just update orchestration, right? But when you onboard all these AKS clusters into that fleet, right? That's what you're asking. What happens? So what happens over there is certain custom resources are created in all of the member clusters. Okay. And also, each of the member clusters will have a reserved namespace created in them in Kubernetes. Okay, nobody else is allowed to touch that namespace except for the controllers that are deployed. So along with the custom resources, there's also a controller deployed to each of the member services. The member services have now this, new namespace, new custom resources and new controllers. So that's kind of the mechanism. How it does it through that namespace, that custom namespace. They use that as a way to talk to the fleet manager itself. Okay, and this is the primary use case is for update management only. Okay, now if you want to use it for resource propagation and for network load balancing, multi-cluster load balancing, which is there are two other features. Then you need a small cluster created for the hub as well. So the fleet manager is not just an Azure resource, it also creates a small AKS hub cluster that goes along with it. And the reason for that is the way resource propagation works is, Cale, is that you actually define your resources that you want to propagate in the hub cluster, and then that gets propagated to all of the member clusters, right? As per your definition of the policy. And so that's kind of why you need that hub cluster, just so that you have a place where you can define those resources that you wish to deploy or roll out. So in that scenario, you need to have the hub cluster there as well, and it just creates a small AKS cluster really, which is used mostly for control plane operation. It's not something that's used on an ongoing basis as such, right? I mean, it is used somewhat for an ongoing basis. And one of the things that it does, what the fleet manager does is, let's say you onboarded 5 clusters onto your fleet, and one of them you want to remove it out. So you can create an operation to remove it out, in which case the fleet manager has to mark that as we're going to remove that cluster, right? So that's one reason why it needs to know that. If you add a new cluster and that cluster falls within the realm of the number of clusters that are under management, like maybe the label is production and you're managing all production servers, all clusters, then it's going to make sure that that new cluster gets all of the resources that the other cluster has, right? So there are some reasons why that ongoing update will happen, but it's not something that is used consistently when you're accessing the application or anything like that. That hub cluster is just a small cluster used for these control plane operations.
That's awesome. So it sounds like basically it supports both models of, hey, I got Greenfield here. I know I'm going to need a bunch of clusters, so I can start with Fleet Manager, have it go do my stuff, everything's cool. Or I already have my clusters and now I want to get them under control, and then I can use it that way. So it does both. That's cool.
Yep. Exactly. And there's a new AZ fleet command in the AZ CLI, which supports most of these operations. You can do some of it from the portal, but from my own experimentation, most of it is available through the AZ fleet command. I strongly recommend you get to know that.
What about like in terms of pricing? Does it cost people to use Fleet Manager? Obviously, you mentioned 2 different ways to run Fleet Manager. One of them is going to run an AKS cluster that's small. I would assume there would be a cost there because there's a node running or something. But if you do the other one, like, is there an additional cost for Fleet Manager? I didn't know.
I don't know if you're talking cost yet because this is still a preview service, but I'm
Gotcha.
sure there'll
Gotcha.
be,
Okay.
there may be some minor costs later on. Like, I expect that, most of the costs are going to be, as you said, in that hub cluster that you have deployed there. Actually, running this is just a matter of some additional CRDs. In fact, it's a good point you mentioned that the one feature for the resource propagation, right, where you can define a bunch of resources in your hub cluster and have them automatically deployed out, rolled out, is also available in the open source. So that's an open source project called Azure Fleet, right? So under Azure/Fleet, if you go to GitHub, you'll see all this. And so you can deploy that to any Kubernetes environment. So because that feature is just something about Kubernetes resources being rolled out, right? It's not tied to a specific cloud provider, right? So it's nothing Azure specific or GCP specific or AWS specific in that feature. So anybody that has a Kubernetes cluster or a bunch of Kubernetes clusters, and you want to ensure that all of them are getting consistent resources deployed, you can do that by yourself. But Azure is providing like a convenient way of doing this, right? Instead of you having to kind of install Helm charts and whatnot in all your clusters and whatnot manually, it kind of does it for you.
I guess one thing we didn't cover, I was thinking about was security aspect. So when you have existing clusters, right, and then you bring one of these fleet managers, you fire it up. How does that authenticate? Do you have to create like a service principal, or is there like a secret or something, or how's that? Do you know, like how's that work?
Yeah, so it creates all these. So, like I mentioned, the special reserved namespace is kind of like a communication channel, right,
Mm,
between all those clusters. And so it's creating these special users, cluster role bindings.
mm,
And then the controllers are the only ones that have access to that reserved namespace. And the reserved namespace essentially contains a bunch of Kubernetes configuration objects, right? So, Kubernetes, you can create configuration objects. And so they use these config objects as a way of, saying, okay, this is where I'm at. Let me see where you're at. And then they can kind of read each other's information
gotcha.
and make sure everybody's synchronized, right? This is particularly important when you use the load balancing feature, right? The multi-cluster load balancing feature. And this is a feature where you could do a level 4 or layer 4 load balancing, like a TCP load balancing across multiple clusters. The main reason for that being, if you have a cluster in one region and a cluster in another region for disaster recovery, for example, or maybe you have clusters in some regions because you want to be closer to where the customers are in that region, you want to be able to load balance sometimes across them. And in order to do that, there's a lot of communication that happens between the hub cluster and the member clusters, right? So this is where that communication really comes into play.
Sounds cool. Yeah, I think that's super cool too that it's like can go across regions, right? Because that's a pretty powerful thing to be able to manage, across there. And I know we kind of glossed over that at the start, or you mentioned a little bit about it, but that's pretty powerful.
Yeah, I think that that's and again, that's one of those features that does require the hub cluster, obviously, because it's very specific to Azure. One of the requirements of that feature is that all your clusters, your AKS clusters, must use Azure CNI as the networking layer, right? As you know, AKS can be deployed with KubeNet or with Azure CNI. There are other uh, CNI implementations as well that are available. But it needs Azure CNI because every IP address of every pod that's deployed has to be on the VNet so that we can load balance across all the pods, right? That's the whole idea, is that now all the pods across all the clusters become one gigantic pool of pods, and then this new form of load balancing across clusters will make sure that all the pods across regions get kind of equal access, and they kind of are load balanced over there. There is one kind of nuance or interesting point when you set that up, Kale. And the way that it works is when you create, you just create, let's say you create an application in Kubernetes. If you create an application in Kubernetes, you just have to create the deployment for the application, and you create a service, right? That's typically what you do. And you can access that service, that application on a specific port, for example. Now, on top of that, right, you have to create this service export. You also deploy a service export, okay? And you can do that in the hub cluster, let the resource propagation propagate it out. Now, all your member clusters have this application up and running, and they don't know about each other at this point, right? They just know that each one of them has their own application and service endpoints that are running. And now the next step, which makes it all interesting, is that you go to one of the member clusters and you say, I want to create this service import feature in this. It's called service import. And so that's going to take is going to take the service that's already running on that cluster and make it available so all the other clusters also see it as one whole cluster. Now, what it does is it takes the load balancer that was currently servicing that cluster and reconfigures the load balancer to work across all the clusters. So that's kind of the process for making this available across clusters. That same load balancer, which was currently servicing cluster one, for example, and that's where you deployed your service import, is now going to be reconfigured to support all of the clusters in your fleet or in that target fleet. So that's kind of how that works. Once you set that up, then the endpoint that you have will just load balance across all the clusters in your fleet. There were a couple of kind of gotchas, I would say, not really gotchas, but they're working on a few things. I mentioned about the regional failover. One of the things is that the fleet manager itself does not support regional failover yet, right? So that's still a potential breaking point. Although it's less of a problem, like I said earlier, that's primarily a control plane operation. Once the in the case where you did the layer 4 load balancing, once the ILB has or the load balancer has been configured, the fleet manager cluster is kind of out of the picture. Right now, it's just normal load balancing that happens. But in case that region goes down, you won't be able to make any changes to the existing setup until the region comes back up. So currently, that is a limitation. The fleet manager resource itself is a regional resource. They're working on making it multi-region. And the other question that does come up is, is Azure Arc supported? And currently, they're working on that. It's not yet supported, but they are hoping to kind of add that on soon.
Nice. Sounds good.
Yeah. Well, thanks, Kate. Thanks for all the questions.